All right, so I was working out the problem on the other video and I made a mistake so I decided just to start fresh. So this was the problem I asked you to try at the end of the class on Wednesday, October 21st. So the first thing we do is, like I said, I number my equations like 1, 2, and 3, and you're going to pick any of your equations. So I just picked the first three, the first and second equation. So I'm going to copy those down. So x plus y minus z equals -1. 4x minus 3y plus 2z equals 16. And you could basically decide what variable you want to get rid of. Honestly, for this problem, since all your coefficients for the first equation are 1, it's pretty easy to get rid of, honestly, any of your variables. But I'm just going to get rid of the x's. But if you got rid of a different variable or you pick different equations to start, your work might look different. But you should see in the end we get the same answers, as long as we both did it correctly. But to get rid of our x's, we could multiply this top equation by -4. So I'm going to write it below. It would be -4x minus 4y plus 4z, because the double negative, equals +4. Your x's cancel. You get -7y plus 6z equals 20. Okay, so that's step 1. Step 2, you're going to pick any other pair of equations. So we did 1 and 2, so we could do equations 1 and 3, or we could do equations 2 and 3. Remember, we have to get rid of our x's. We have to do the same thing, get rid of the same variable we did in step 1. So I don't know, you might just want to check just to see which one looks easier. But for 1 and 3, our x's, we have a coefficient of 1 and a coefficient of 2, so that wouldn't be too bad. Same with equations 2 and 3. You have 4x and 2x. That wouldn't be too bad to eliminate. So you probably want to check before you commit, but if you ever do write it down and you're like, oh, this looks kind of messy, you can always try the other option. But I'm going to do equations 1 and 3. So let me copy those down. So x plus y minus z equals -1. 2x minus 2y minus 3z equals 5. So we have to get rid of our x's. So I could multiply this top equation by -2. That would give me -2x minus 2y plus 2z equals +2. If we do our elimination, our x's cancel. We get -4y plus 1z equals 7. And oopsie daisy, I made one error. -3z plus 2z would have been, minus 1z. So sorry, I noticed something was off, so I paused the video. That's when I made a mistake when I was combining these. So that should be our second equation. So sorry if you were looking at that when I was writing that down and like, no, it's wrong. I'm running a little low on space, so I'm gonna just do step 3 here. But step 3, we're gonna put these two equations together. So I'm just gonna copy that -7y plus 6z equals 20, and our -4y minus 1z equals 7. So we want to get rid of either of our variables, either the y's or the z's, but the z's look a little bit easier because to get the opposite of 6z, I could just multiply the bottom by 6. So that would be -24y minus 6z. 7 times 6 is 42. So if we do our elimination, we would get -31y. Z's go away. 42 plus 20 would be 62. If we divide, we'll get our y is -2. So we can plug this result into either one of these equations we had here or here. I don't know, I'm going to plug it into this one here. So -4 times -2 would be +8. Minus 1z equals 7. If we subtract the 8 over, I'd have -1z equals -1. Divide, you'll get z is +1. So now that we've got both of our answers, and sorry, it's a little bit of a mess, we can plug this into any of our original equations. So I'm just going to plug it into the top one. So if I do that, I don't know what my x is. I'm just going to write it down here, by the way. My z was -2, or sorry, my y was -2, so it's going to be -2. My z was 1, so it's going to be -1 equals -1. So that would be x minus 3 equals -1. If you solve that, you'll get x is 2. So our final answer would be, is our ordered triple 2, -2, 1, your x, y, and z.